Good morning. In the past two lectures, we've talked about resistor combination and source combination. Okay, can someone tell me what is the goal of these two methods, source combination and resistor combination? Why do we employ them? To simplify the circuit, okay? Today we're going to talk about superposition, linearity and superposition, which is another way of simplifying the circuit, okay? Now, we say a system is linear if it has two properties. Let's talk about the first one, which is called additivity, okay? Let's see what it means. So consider a system, one system, okay? So these blocks that you see here, they are all one system. Now, let's focus on the inputs and outputs. So imagine that, or assume that, we are giving an input to that system, and the input is called x1. And let's call the associated output as v1, okay? Sorry, y1. So x1 and y1. And remember, there is no limiting assumption here, okay? This is very general. So I'm just assuming the name of the input as x1, the name of the output as y1. That's it. Now, if I enter or if I give another input to the same system, obviously, generally, it's going to generate another output, right? If we want to be general. So let's call that x2, and let's call the associated output as y2. Now, what happens if I give both of these inputs at the same time to the system? x1 plus x2. Then the output is going to be y1 plus y2. Does it happen all the time? No. We're going to give you some example for that. When that happens, we call the system additive. It means that if you have n different inputs, and if you add all of them together and give it to the system, the output, the overall output of the system is going to be all the individual outputs summed together, okay? So let's give you an example to see what's going on. I'm going to come back to this note and highlight it for the important parts. So let's, first of all, before talking about this example, can someone give me a definition of a system? Very general engineering question. What's the definition of a system? And that's correct, but that's higher level. I mean, I want a very basic definition of system. I mean, yeah, exactly. I was looking for that. It receives an input, it does something to the input, and it gives out an output. That's the general definition of a system. Now, for example, if you look at this, we can define a system. How? For example, let's consider the current source as the input, and let's consider the voltage across the resistor as the output, okay? We are free to choose so. So let's consider this as input, and let's consider this V10 as the output. Can someone tell me what this system is doing to the input to give out the output? You don't have to complicate things. Just look at the circuit and find the relationship between the output and the input. What is the relationship?
It's multiplying it by the resistor value.
Yes. Do you agree with that? Ohm's law. Now, let's consider IS as 1 amps. What is V10? 10 volts. Let's consider IS as 5 amps. What is V10? 50 volts. Now let's consider IS being 1 amp plus 5 amp, which is equal to 6 amp. What is V10 equal to? Right? Okay. I'm going to write that as 50 volts plus 10 volts. And I'm going to ask you a question. When you answered my third question as 60, how did you calculate 60? Did you multiply 6 by 10, or did you add 10 and 50? 6 by 10. Everyone? So that's the natural, original, always correct way of doing things. Referring to the system equation. Let me This is system equation. Can I use the other way of calculating the output for 6 amps? Can I just add 10 and 50? Or no? Always? When can I do that? When the system is additive. Otherwise, you can't. You're not allowed to do this. I'm going to give you an example. So I'm going to write it like that so you will remember. This is called let me maybe change the notation. Write it as IS1, IS2, and then V10 1 and V10 2, and then I can do this. 1 amp is actually IS1, and this is IS2. Now 50 volt is V10 2, and this one is V10 1. What it means is that the output to the combined input is equal to sum of the outputs. Okay, if it's confusing as a sentence, just always remember this example. It doesn't matter if I multiply 6 by 10 or if I add 10 and 50. They both give you the same answer because the system is additive. Let's talk about this system. Now, let's again do this. Let's consider X1 as, use blue. Let's consider X1 to be 3. I don't care about the units, okay? This is a general system. And X2 equal to 5. Can you tell me what is Y1, the associated output? 9, right? See? Do you see the system equation? Whatever comes to the input gets squared, goes to the output. So Y1 is equal to 3 squared, which is 9. Y2 is equal to 5 squared, which is 25. Now, let's consider X being X1 plus X2, which is 3 plus 5 which is 8. What is y associated with that? 64. Now, if I calculate y1 plus y2, what is that? 34, right? Is y equal to y1 plus y2? No. What should we call this system? Non-additive. Okay? It's not additive. Was it obvious before doing this example? How? Look at the system equation. Is it screaming I'm not additive? Because it's a squared, right? So this is not additive, and this is additive. Okay? Any problem with understanding additivity? No? Let's talk about the second property of linear systems, which is called homogeneity. Okay, I have a system. Again, I'm talking about one single system. And the input is x, the output is y. Now, let's multiply the input by k, for example. Okay? If the system is homogeneous, the output is going to be multiplied by the same number. So the output is going to be k, y as well. Okay? Let's apply it to the same circuit that we considered previously. So this was input, and this is output. Right? Instead of giving you like numerical examples and showing you that this is a homogeneous system, I'm going to mathematically prove it by just one line of mathematical manipulation. So can someone tell me what is the system equation for this circuit? Equal to 10 is, right? Now, what happens if I want to calculate the output of 10 times the input? Do you agree that I should replace the input by its by 10 is? So instead of is, I'm sorry, KIS, right? Instead of is, I've substituted KIS. So what is the final result? Do you agree that I can exchange the place of k and 10? What can I write instead of 10 is? V10. Right? So what does it mean? It means if you multiply the input by 10, what happens to the output? Gets multiplied by 10. That's called homogeneous. So if a system has these two properties, it means that it is linear. Do you have a problem with this proof? Do you prefer the numerical example? I wanted to do it both ways, so. And let's see it for the other one. So y is x squared t, right? This is the system equation. Yk which is the associated output for when the input is multiplied by k. So instead of x, what should I write? Kx, right? What happens to the output?
Just multiply by k squared.
Yeah. Is it equal to your original y? No, it's not. Because k is squared. In the original y, I mean, you don't have that, right? Sorry, I should write ky. It's not equal to ky. You don't have to prove this in any problem or anything or on exam, and you don't have to prove anything about linearity and superposition. That's for higher level courses, but I want you to understand that this is what kind of advantages we'll get from this property, from linearity. Now that we talked about homogeneity and additivity, we can say that any system that has these two properties together, it's called a linear system, okay? And we're going to talk about how we can handle these systems. So any system that has these two properties, it's called linear. Let's see what happens. First of all, let's look at these block diagrams and see if we agree with the final one, the bottom one. So I have assumed I have a single system. Again, remember, these are not different systems, one single system. In different occasions, I apply different inputs to the system. And each input will generate a different output. So x1, y1, x2, y2, xn, yn. If the system is linear and I apply all the input together, what should be the output? All the individual output sum together if the system is linear, right? And see the input? So instead of x1, I have a multiple of x1. Then I have a multiple of x2, multiple of xn. All of them added together, given to the system. And if you look at the output, k1 is exactly like the input. y1 is associated with the x1. Then k2, exactly like k2, y2 associated with x2, and so on and so forth, okay? So only if the system is linear, we have this property. Can someone tell me why this could be important in simplifying the circuits? Let me give you a hint. From the example that I did, the simple current source and the voltage that we just did. In circuits, what do we usually consider as inputs of the system? Independent sources, either voltage or current sources. Now, can you tell me what kind of advantage this will give us?
Combine multiple sources to each other.
Actually, the opposite. What can we do? If we have multiple sources, like 10 sources in our circuit, what can we do? We can remove 9 of them, only consider one of them, solve the circuit, find the answer. Keep it somewhere. Then do it for the second, third, up to 9th. Find all the individual outputs and then add them together. That's only possible for linear systems, okay? So let's get back to here and see. Let me see if I have it. Okay, yeah, I have it here, so it's better to just talk about it here. So this is a sort of a summary of what superposition is, okay? Superposition is an advantage that we can apply to systems because the system is linear. Now, any linear circuit. The good thing is that everything in this course, every circuit in this course is linear, unless a system is provided you in web work, specifically giving you some system equation that is not linear. Any circuit made of resistors, capacitors, inductors, voltage sources, and everything is a linear circuit. So that is good news. Now, if the circuit has several independent sources, very important, do we consider dependent sources as inputs? No. Why not? Give me a logical reason so you don't forget it. Imagine you have 9 independent sources and 1 dependent source, okay? Can I consider 10 inputs to my system or no? Why not?
Because one of your input sources has a variable.
Okay, so what? What's wrong with that?
Answer can change.
But that happens all the time in our circuit. Doesn't violate any laws, does it? So what's wrong with considering a dependent source as your input? Let me give you a specific case. So I'm allowed to remove all of them and keep only one of them in circuit and analyze it, right? So imagine that you have 10 sources. One of them is dependent, 9 of them are independent. If I remove the 9 independent sources, is there anything else to even analyze in the circuit? Everything is dead. Because dependent sources won't energize the circuit, right? They don't give anything, any power to the circuit unless there are some independent sources, okay? So remember, only independent sources. Then we can find any voltage or current in the circuit by this method. First, keep only one independent source and eliminate the rest. Okay? We are going to eliminate the rest of the independent sources. How are we going to do that? You have 2 classes of independent sources, voltage and current. How do you eliminate voltage sources? You replace them with short circuit. That's very important. Replace voltage sources by short circuit and replace current sources by open circuit. Because if eliminating mathematically means setting them equal to 0. How do you make a voltage source 0? You don't open it because that's not going to change the voltage. The voltage is still going to be the same. What happens if I short it? Then it becomes 0. For example, for current source, current is pushed in the branch. Unless you open it, then it becomes 0. Okay? Now, after we did this, we're going to repeat this process for all the independent sources in the circuit. I'm going to read this and I'm going to underline a very important keyword. So repeat this for all independent sources to find their corresponding contribution in the voltage or current that we want to find. So I don't know how to put more emphasis on this, but like this. Very important keyword in the sense that it actually tells you when linearity and superposition are being employed, are being used in that specific question. So if you see that keyword, right away, you have to think about linearity and superposition. Now, after we did this for every single independent source, what's the final step? Add all of them together. And in adding them, you have to be very careful to algebraically add them. Okay? Not only the magnitudes. So for example, if one source is giving the value of a voltage as 5 and the other one is giving -2, the overall is 3. Okay, so you have to respect the signs as well. So the algebraic sum of individual values. Let's apply that to a circuit and see what I mean by that. Determine Ix. Okay. The first I'm going to use superposition. Okay. What should I do? Yeah, so I have to consider all the independent sources separately, right? So first, let's consider only the voltage source. I'm going to copy the circuit, put it here, and what should I do to the other one, to the current source?
Make it switch.
I opened it, right? So what happens to this circuit if I open it? Can you simplify it a little bit for me? How? Do you agree with this? Do you agree that this is the circuit that you have to analyze? I just got rid of one independent sources. I have to change one label in my circuit if I want to be very strict about the laws of labeling. So do you think calling this current in the middle branch Ix is it technically correct to call it Ix? No, because Ix is due to both of the sources. So what should I call it? You can either call it Ix1 or I'm going to call it I prime X. The same goes with this one. Okay? I prime X. You know why it has a different name than Ix, right? Ix is because of two sources. This is only because of one voltage source. I want someone to give a proper expression, statement for I prime X.
I prime X equal
No, not a mathematical, just in words, just a verbal explanation of what I prime X is. I actually made it quite clear that this is the most important keyword in this context. So can you tell me what is the explanation or what is the description of I prime X? I prime X is the corresponding contribution of the 3-volt voltage source in or to, what should we use, to or in for You should know it. I shouldn't. Is the corresponding contribution of the 3-volt voltage source, I think in is, in Ix. Did that make sense to everyone? I'm going to write it and then we're going to read it again. So, the corresponding contribution of the 3 volts voltage source. Seriously, should we use in or to after contributing? To, right? You don't have any idea? Is it to or in? To? Okay. 2Ix. Now, see if that makes sense, if it is confusing, if there's any problem, need clarification, let me know. Does it make sense? So I prime x is the part of Ix that is due to the 3 volts voltage source. Okay? So let's see if I can find it. What is I prime x? Very easy. Sorry? Tell me how to write it. 3 volts divided by the equivalent resistance of the whole circuit, right? And the answer is 0.2. 3 over 15, 1 over 5.2. 0.2 amps. Any problem? The second step is to, let's consider the current source this time. Okay, so I'm going to copy the circuit again. Put it here. What should I do? I should short circuit this thing. Do I need to change anything in the right side circuit? I double prime, for example. And I don't feel like writing this again, so I'm gonna add this double prime here. What's the only thing that I should change here? 2 amp current source. Agree with that? I double prime is the contribution, the corresponding contribution of the current source. So I need to find I double prime x. What is that? I'm looking for a smart idea, very smart idea. I know that it can be done many ways, but I'm looking for the best one.
You can find the voltage across the 9 ohm resistors by taking the equivalent resistance and multiply it by the 2 amp circuit,
completely correct, but that's not the best way.
Then current division?
Current division. That's the best, the smartest move here, okay? See, you have 2 amps current coming, and it's going to be divided between 6 and 9. So what is the equation that I should write? First, write the thing that is going to be divided. 2 amps. Then you need a fraction. What is that fraction? 6 ohms over 6 ohms plus 9 ohms. And that's equal to 0.8 amps. See, this is the idea of a current division. This guy is going this way. Now, it's getting divided. Right? That's the idea behind the current division. It's getting divided between 6 and 9. Okay. So we have I prime and I double prime, right? So what is Ix? I prime x plus I double prime x, which is 0.2 amps plus 0.8 amps, which is equal to 1 amps. Yes?
Why do we not do current division for both of their resistors? Like you just did 6 over 6 plus 9. Why do we not do 9 over 6 plus 9 too?
That will give you the current in the other branch. You could find it, but you don't need it. Okay, I get what the problem is. This is the formula. Does that sound better or no? So, see, if you remember the equations or the formulas for current division, answer this question first. If I increase the resistance of a branch, will the current decrease or increase? Decrease, okay? That's why it's actually proportional to inverse of the resistor, okay? But I also gave you another formula, which is what usually electrical engineers use, and this is the equation. So the 2 amps is the same. Instead of dealing with the inverse of the resistors, I deal with the resistor in the other branch. That's why I write it as 6 ohm divided by 9 ohm plus 6 ohm. They both give you the same number. Did I answer your question?
That makes more sense.
Okay. So either one of these are you can use. And remember that the final step and the final result is because of superposition. Otherwise, if the system wasn't linear, if the circuit wasn't linear, you are not allowed to use that. Just one quick note about linearity, now that we did an example. Can you give me an example of a linear system in nature?
Tadpole becomes a frog.
Pardon me?
Like how a tadpole becomes a frog.
What else? No, I'm not saying that's bad. I'm just looking for them. Do you happen to know the input-output relationship for that? No?
You throw eggs in the water and then tadpole comes out.
But how do you say it's linear exactly?
So tadpole goes through multiple steps before it becomes a frog, and then cycle.
Can you give me some other examples, please? Other examples, like engineering systems. Any engineering system that is linear. Have you ever dealt with any concept in your courses about linearity?
Superposition on like trusses.
Is that linear? Linear what? Okay. So let me tell you this. If I ask you another question, what percentage of a system in nature do you guess to be linear? Say? What else? 0%. We don't have anything linear in nature. It's impossible to have something linear in nature. No question. So why the hell do we think that's a good idea to learn about them? If nothing is nature is linear. Well, let me ask you this. I want you to feel what linearity is about. So I'm going to plot something for you. Okay? I'm going to plot something for you. Can someone tell me what is the root of the word linear? Line, right? So if I draw the output-input characteristic of a linear system, what should it look like? A straight line, right? So every system in nature is nonlinear. Something like that. So as I mentioned, why do we even consider systems to be linear? Or why do we learn about linear system and all the advantages? Can someone point that out to me or no?
Because it's easier to understand.
But it's wrong. What's the point of that? Do you want to take a course on flat Earth? Because it's easy, probably? No. Oh, I hope no one is here believing in that.
I know when we read data, we make it linear. Like
How? You changed that data?
I mean, you like,
Really?
round.
How can you make a system linear? It's non-linear. Look at this. Let me make it a little neater. It's obviously non-linear, right? Do you all agree? This is not a line. So how do you make this linear?
You take the average, get your amount.
Why? There's no justification for taking the average of something. If the values are changing drastically, there's no point in it. How about now? Focus on this range. Is it linear? It's very close to linear, right? Or for example, focus on this range. Seems very linear to me. Focus on this range. In that range, it seems very linear actually. So what's the point of linear systems? Because when you are talking about the overall characteristic, it might be nonlinear, but limiting the input to a very small range actually makes all the change. So you might be able to actually consider the system linear over small ranges, which are practical. For example, let me give you an example if I can find something. It is probably just wrong, but helps you understand the concept. Like for example, the amount of pressure that I put on the gas pedal or let me put it this way. The car speed is a function of the amount of pressure I put on the gas pedal, right? Obviously. Imagine that it's linear for the range of 50 to 120 miles. But when you move to 300 miles, it becomes nonlinear. Who cares? Who cares that at 300 miles it's nonlinear? I'm interested about, for example, between 50 and 120. Then I can give you a model of the system. Yes, the model is not going to work at 5 miles an hour. The model is not going to work at 300 miles an hour. But still, it's very good fit for the range of most of the practical speed ranges that I'm dealing with. Okay, so do you get the importance of this concept? That's, I hope it was clear. So, okay. Let me do this. Let's get back to our example and solving the example. Without superposition. How can I solve this? What do you suggest? I'm not saying that you cannot solve this, but if you can't, don't feel bad because we haven't learned any systematic way of handling this. But I would be very happy if you can. How do you think we can approach this?
Analyze the meshes.
Analyze the meshes is one way. Yeah, definitely. How many meshes do you have? Two. Is there a reason you chose meshes over nodes?
Because the node has a reason to direct on top of it, one of the nodes. There would be more nodes than
How many nodes do you think we have? 3? Okay. Let's see. One of them is here. Do we count them in the number of unknowns that it will we will end up having? No, because this we usually call what? Ground. So this, it's fine. What else? We have one node here. And let's call it, what do you want to call it? Vx is fine, associated with the Ix, huh? Let's call it Vx. And how about that one? What should I call that? Huh? Should I give it a label or no? Just 3. It's not an unknown. Do you all see that? Do you see the battery connected between ground and that node? So it's not even an unknown. So technically, how many unknowns do you have if you go for nodes? Only one, Vx. So that's not very bad. actually. Very important question. Should I go for nodal? You don't know nodal. Should I analyze the nodes, or there is a much smarter way of doing things here? Sorry? I don't understand. I don't hear it. KCL is dealing with the nodes. They are technically the same thing. Is there any much smarter move here or no? Something similar that we've talked about. See, that current is going and then it's going to be divided, right? Can I apply current division here? I want you to understand that because that's very important not to use it here. And I want you to know why you're not allowed to use current division for this case.
There's not a note there.
Let me put it this way. What element is stopping you to apply current division to the circuit? The voltage source. The only way that you can apply current division is that the two resistors must be in parallel. Are they? No. What is stopping you from considering them parallel? The 3 volt voltage source. Why were we allowed to do that before? Because we were using superposition. Okay? So you're not allowed to use current division here. What should I do the way that you've described it? Can I just write a KCL at Vx? Let's write it and see what happens. Let's start with Ava. Can you start the KCL, please? At Vx. Remember, we write all the currents going into or leaving that specific node with the convention of entering is negative, leaving is positive. And remember the red box, the red box. Minus 2 amps. What's next?
Plus IX or plus I?
You want to write plus IX? Can you tell me what that is before without using IX?
9/3 volts, so 3 amps.
9 over?
9/x.
Use the red box. Do you remember the red box? Can someone tell me what was it? This is that one. So can you tell me what's the current leaving the red node to the left or going down? What is the current going down from Vx, going down through the 9 ohm resistor? Vx minus 0 divided by 9 plus what is the current leaving the red node toward the purple node? Vx minus 3 divided by 6 is equal to 0, right? 1 KCL. Let's multiply both sides by 18 to get rid of everything. 18, it becomes negative 36 plus 2Vx plus 3Vx minus 9 is equal to 0. 5Vx is equal to 36 and 9 becomes 45. 45, then Vx becomes 9 volts. If Vx is 9 volt, what is Ix? 1 amps. Did I get the same answer? Of course. Did I consider both of them at the same time? Yes. So, when should I use superposition? Usually students, avoid using it whenever they can, okay? You have to use it under certain circumstances. One of them is if you see that keyword. What was it? Corresponding contribution or contribution, okay? Contribution of that specific source, you have to use superposition. So that is the only time that you have to use it. Otherwise, usually a student ignore it. For the third exam, you have to consider it more often. But it's up to you. You prefer handling one more complicated circuit or several easier circuits. That's the whole idea. Let's solve this using superposition. First, consider only the 10 volt. So what should I do? The current source should be open, and the other voltage source should be replaced with a short circuit, right? 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 Should I replace that voltage source with a piece of wire? It's not independent. Leave it alone. Don't touch it, okay? It's about to take off. Okay, I'm getting rid of the middle branch. Can I combine 1 ohm and 2 ohms? Isn't there any problem because one of them actually Ix passes and I have a dependent source which depends on Ix? Is it okay if I'm combining 1 ohms and 2 ohms? Why yes? Because the current won't change, right? The current passing through the combination is also going to be Ix. I'm not changing anything. I'm not destroying the variable. So this is 3 ohms, and this guy is still Ix, but it's better to call it I prime. And this one to I prime x. Okay, how do you solve this? KVL. Write it yourself. I'm going to do it some other way. Do you agree that it's technically KVL, but I'm going to write it like in a shortcut way? So do you agree with this or no? Can you tell me what kind of a law is that? Ohm's law, right? Look at the resistor in between. I consider I prime X entering from the left as the positive terminal. So the positive terminal is 10 volt, the negative terminal is 2I prime X. I'm using that red box again. So whatever you're more comfortable with using, it's the same. Let me just write the final value here. It's 2. Let me see if 2 works. 10 minus 4, 6, yeah. So I prime X is 2 amps. Okay? Next, consider only the 3 amps. What should I do? Short circuit both of the voltage source, right? I'm getting rid of everything else. What's wrong? Don't touch the dependent source. Only the independent one. I'm going to change my label to I prime. I prime. So, can I apply current division? What's wrong with that? The dependent source is bothering us. So, what do you suggest we use? Any idea? KCL, okay. So let me find the nodes here. I have this node. Oops. What should I call this? Let's call it just V. And I also have this node. Should I label that purple node, or there's already a label that I better use? What is that? 2I double prime X, right? Is there any problem with calling that V2? No. What's going to happen? You're adding a variable to all of your calculations, okay? So it's better to use 2I double prime. Now, I'm going to do something on the circuit. That's a little advanced, okay? But I prefer if you start doing that as soon as you can. You may survive without doing that, okay? You may get a B or even A. But I very much prefer, for saving time, to start doing that. And that's when I try to let me see. Yeah, I'm gonna do it anyway, so you know what I mean by that. Most of the time, when one of my node is a dependent variable, for example, to the I double prime, okay? It's not a number. I try to simplify it as much as I can. For example, in this circuit, do you see any, or do you have any related expression for I double prime x that can replace it? Is there any way in the circuit that you can write an expression for I double prime x?
You can replace the I double prime x with b minus 0 over 2.
Small mistake. 0 minus v. You still not believing me that this is the most important thing in this course? 0 minus, because of the direction, right? So do you all agree with this? 2, 0 minus v divided by 2, and it's equal to negative v. Do you see why is it useful? Because you can easily substitute one with another. So it's very good practice to try to find the relationship between variables. Now, let's write KCL. KCL at V. Let's start with, yes?
Why would it be 0 minus v over 2 instead of 1?
Where's 1? Okay, where is I double prime Ernest?
Top right node.
No. Where is I double prime x?
Oh, okay.
Do you see the problem? Yeah. That's a very common issue. So I double prime is not there to the right. It's actually, it only depends on. The real one is top left. So let's write KCL at V. Will, can you tell me what is it? I want to write KCL.
Okay, I double prime times 2 ohm.
KCL.
Oh, CL.
Yeah.
V minus 0 over 2 ohm.
V minus 0 over 2. Plus, next, Erin. Oh, sorry, Erin is there. What was her name? Yeah. Gloria, can you tell me the next, please? The one going down. What term is associated with that? Negative 3. Yeah. And the one going to the right, what's that? Yeah. Use the red box. The right branch, the current that's leaving the red node to the right. Not minus 0, V minus. V minus negative V divided by 1 equal to 0. Do you see the advantage of simplifying on the circuit? What's the advantage? I avoided having two unknowns in my equation. But what was the better choice of variable in writing the KCL? Using I double prime rather than V, because ultimately we want to find I double prime. These are all just tricks, okay? Nothing to do with the scientific facts or anything. These are just tricks of solving the equation. I can write it like that. Or, now I'm going to repeat the KCL process. Can someone tell me the whole KCL equation not using V this time? Who can do that? Negative I double prime X minus 3 amps no. No. Plus what?
minus V over R. Or 1.
Is there any way that you avoid using V? You can, because the other branch is actually using the red box, so we have to use V minus, even if you use 2I double prime, you're gonna end up using V anyway, okay? But I'm gonna write it just so you know. V minus 2I double prime X over 1 is equal to 0. So the first one, as you see it, that's the way to get rid of that. What's the point of that? You can solve one equation, one unknown. Let me see, what's the value? That is 2V and 5 over 2V, 3 to the 6 over 5. Am I right? 6 over 5? 2V and 4, 5 over 2. Why am I getting 1.2? Am I correct? 2. I don't have the values here.
6 over 5.
Which is
1.2.
1.2, right? And what's the other one? Did I write something wrong here? V minus 0 over 2 minus 3. V minus negative V over 1 is equal to 0. Let's multiply by 2 and see. V minus 6 plus 4V is equal to 0. V is equal to 1.2 volts. If V is equal to 1.2, then 2I double prime X is equal to negative V is equal to negative 1.2, which means I double prime X is equal to negative 0.6 amps. So can someone tell me what is IX?
1.4 amps.
Yeah. What was it, 2? .4 amps. Okay. You don't have to worry about how to solve these circuits right now, because you're going to learn them as we move forward. This is not the main concern of this lecture. The main concern was the application of linearity and superposition, and to see that you are allowed to use that. Any question? No? Am I done? Yes. You can start working on your in-class assignment.